three-lot approach in the goals of carbon neutrality and carbon peak, and given the severe situation of global climate change, we're seeing the popping up of the new round of energy revolution. Hydrogen as a new source of clean energy has become a choice for countries across the world. In terms of their energy choices, hydrogen cell battery as important carrier of hydrogen power has received extensive attention and intensive development. So our next speaker, Ms. Wang, Secretary General of the International Hydrogen Fuel Cell Association, IHFCA. She is going to do a keynote speech on the industry development report of international hydrogen fuel cell industry. Thank you very much, and I am honored to be invited to attend the 2022 Shanghai Platinum Week and the China PGM Summit. I am really honored, and I'm happy to present to you the status quo of hydrogen industry around the world. At the very beginning, we heard from the presentations by previous speakers about the hydrogen fuel cell power or fuel cell. Well, as we are gradually working towards a high carbon peak, hydrogen has received extensive attention, and there is a consensus for the need and demand for hydrogen. Going forward, we are going to see more demand for hydrogen. So today, I am going to present to you how we see the hydrogen development and industry. There are three things I will cover today. Firstly, I'm going to present the overall industry background of hydrogen, as this is relevant to all of you. And then at the very end, I am going to talk about the issue that's of great concern to all of you in this industry, how hydrogen is relevant to PGM market. And I'm also going to present to you our predictions about the demand for PGM in the future. So first of all, developing hydrogen is already something of consensus to all us, as hydrogen has a lot of advantages. Firstly, it has great energy density, it's clean, it has extensive applications. Actually, a couple of decades ago, hydrogen already found extensive applications in industry. As we raised the goals of achieving carbon peak and carbon neutrality, hydrogen, PV, and wind power, they can couple, and they are used together, or when they're used together, they can contribute to a GHG emission reductions. That's why it is of great relevance to grow hydrogen power. What's more, historically, every time when we started a new round of energy revolution, power system and hydrogen transition and transformation themselves are very important pillars of such revolution, and they are landmark events. So we see in many industries that people generally believe that hydrogen and hydrogen fuel cell will also be an important driver for the energy industry going forward. That's why hydrogen has received extensive attention from people from across the world. While in the past, as you might know yourself, traditional energy sources, including petroleum, coal, and natural gas, were predominant sources of energy. However, many countries have already raised, including Japan, that by 2050, they will primarily rely on hydrogen as the primary source of energy. China also proposed that by 2050, we will mainly rely on hydrogen and electricity as the predominant sources of energy. So gradually we'll shift from high carbon emissions to low carbon emissions, even zero carbon emissions and negative carbon emissions as we go forward. So around 2017, around 30 countries and regions raised their roadmap for developing fuel cell or hydrogen fuel cell. Japan was first to raise such goals, followed by the United States and the European Union. In addition to roadmap, there has been such proposals as plans and growth strategies. China, in the recent 2 years, have paid great attention to the development of hydrogen. For example, last year, China's National Energy Bureau proposed or issued China Hydrogen Industry Medium to Long-Term Development Plan 2021 to 2035, which is a landmark event because in this plan, for the first time, hydrogen is defined as an energy, and it will be an important component of China's energy mix going forward. Before this plan, hydrogen is just a hazardous chemical materials, is a fuel, so hydrogen is only confined to certain industrial areas. But after this plan, after hydrogen is determined as a hydrogen as an energy source, it will be of more and increasing relevance. In addition to that, the plan raised goals for growing fuel cell, including by 2035 we will develop fuel cell vehicles. Also, it raised a lot of, or it proposed a comprehensive framework for the application of hydrogen in many other areas, including in manufacturing and other industries. So I've just given you overall background of hydrogen development and hydrogen industry in China. Now I want to talk about both supply and demand side of hydrogen, and I would like to talk about the status quo of both the demand side and supply side of hydrogen and how it will grow in the future. Hydrogen is a secondary energy source, so it can be produced in various ways. Currently, we see most frequently the production of hydrogen with industrial byproducts. For example, in Shanghai, we have a lot of petrochemical plants and we have coal-fired plants, so their byproducts can be used to produce hydrogen. In addition to that, hydrogen can also be produced from traditional or conventional hydrocarbon-based sources, including petrochemicals, but there are new ways of producing energy in hydrogen, including biofuel, and we can use water electrolysis to produce hydrogen as well. But as we say that we can use green power to produce green hydrogen, or we can use renewable energy to produce hydrogen, which will represent an important direction for the future growth. So this slide showed you the overall distribution globally of hydrogen production. Globally, mainly hydrogen is produced from natural gas. If you take a look at the pie chart on the right-hand side, it shows the overall distribution or the overall production structure of hydrogen in China. Mainly we use coal to produce hydrogen, and in this process we emit a lot of carbon dioxide. So in the future, we will rely more on renewable energy, while the right-hand side shows the huge demand for hydrogen as we are embracing an era of hydrogen. So United States, in Europe, as well as in other areas, we are seeing the construction of mega hydrogen production centers, including in China. Recently, we started the construction of a mega hydrogen production center in West China in the Xinjiang province. So this slide showed you the overall planning and roadmap by countries across the world regarding development of hydrogen. As you can see on the chart, the United States, Japan, and many other countries have proposed very clearly how much hydrogen or how much installed capacity of hydrogen they want to reach by 2030. So we'll expect that by 2050, hydrogen will account for about 10 to 20% of the final consumption of energy. So I just covered or I just presented to you the production of hydrogen. Hydrogen itself is very light. In many scenarios and in many areas, we use renewable energy to produce hydrogen. However, in the case of China, as you know yourself, that a lot of renewable energy is sourced from West China. So how can such renewable energy be transported from West China to urban areas, which are more frequently located in Eastern China? That regards or that concerns or requires transportation of hydrogen. There are various ways of storing hydrogen and transporting them. Firstly and foremost, most frequently compressed gaseous hydrogen storage is number one, and cryogenic liquid hydrogen storage is extensively used in the United States and in Europe. We are experimenting with this method of storing hydrogen ourselves. However, due to policy reasons, that doesn't account for the lion's share in China. A lot of experts also talk about the use of ammonia, as ammonia has some natural advantages on this front. So we propose such pathways of liquid ammonia to ship and hydrogen. There are other ways of using organic materials to store hydrogen, but this is only at the experimental phase as we haven't figured out the best organic material for storing and transporting hydrogen. That's the overall situation of hydrogen transportation and storage. As I mentioned, that gaseous hydrogen is most frequently seen method of storing hydrogen. In other words, we just store hydrogen in high-pressure gaseous bottle. Currently, in the industrial area, mostly such bottles are used. They represent the primary demand. So in a lot of manufacturers of vehicles, they use mostly type 4. And in China, we mainly use type 3. Going forward, such bottles, we will make them of higher pressure, whereas of lower weight in order to put them on tank. So much about the production, transportation, and storage of hydrogen. Another thing that's of concern to you is the application of hydrogen. Where can hydrogen be used? Hydrogen is most frequently and extensively used in the industry. So for China, for the past several decades, China has been the largest consumer of hydrogen. In addition to manufacturing, hydrogen can also find its applications in transportation as well as in vehicles. Later on, I'm going to talk about how hydrogen can be applied in the vehicle industry in greater detail. Well, hydrogen is also used in energy storage as it has this advantage of long cycle compared with electricity. That's why we need to develop hydrogen. Currently, in countries like Japan, South Korea, hydrogen is also used to power buildings. For example, in Japan, about 300,000 households are also using hydrogen fuel cell in the mix of CHP. South Korea also uses this a lot. In China, we have some pilot projects in Shandong province using hydrogen to power or to charge hydrogen fuel cells, which represent a major application area going forward. The chart shows you the overall situation of consumption of hydrogen in China and also shows that as we are braced for the new energy era, global demand for hydrogen will keep going up. According to some scenario forecasts by IEA, by 2070, global demand for hydrogen will be 7 times higher than the current level of 70 million tons, and transportation demand for hydrogen will keep going up. And I mentioned that hydrogen can be used in the area of transportation. In particular, it has extensive applications in vehicles. If hydrogen were to be used to vehicles, there must be hydrogen refilling stations, just like the way we build gas refilling stations. In other words, if we were to have hydrogen-powered vehicles or if we were to develop hydrogen fuel cell vehicles, there must be hydrogen refilling vehicles around the world. In total, there were 685 gas refilling stations at the end of 2021 in Shanghai, in Jiading, and in other districts. There are also hydrogen refilling stations, and Jiading sees a large ownership of fuel cell vehicles. So if you're interested, you can visit Jiading district yourself. In addition to the vehicle area, there have been experiments regarding how hydrogen can be used in aircrafts and in vessels, including Airbus. Airbus has around 10 aircrafts running on a pilot basis, powered by hydrogen in Europe. Alstom has already developed several hydrogen fuel cell vehicles that are already driving or running on the road. As for hydrogen-powered vessels, by the way, hydrogen has some natural advantages compared with electricity-powered vessels, as hydrogen is lighter and it has longer range. That's why hydrogen has extensive applications in heavy-duty vessels and vehicles. So I just talked so much about demand, consumption of hydrogen. I just want to focus on how hydrogen is used in fuel cell vehicles or in the area of transportation in general. So this chart gives you a comparison of hydrogen-powered vehicles and traditional vehicles. So if we were to switch or if we were to replace traditional vehicles with fuel cell vehicles, you see a lot of changes have to be made to the several components of the vehicle. Well, indeed, hydrogen fuel cell vehicles regarding the ownership, the number is not small. Currently, globally, ownership of a hydrogen fuel cell vehicle exceeds 50,000, and in Korea, the number exceeds 20,000 because the Korean government has strong support for such vehicles. Japan, Toyota was the first company to develop hydrogen fuel cell vehicles, and they sell their hydrogen fuel cell vehicles globally. They sell most to Europe and the United States, even more than the number of vehicles running inside Japan, mainly constrained by the number of hydrogen refilling stations in Japan. So this chart shows you the overview of the ownership of hydrogen fuel cell vehicles globally. As you can see from this pie chart that Korea has the largest number, and in China, thanks to the issue of several support policies, including 5 ministries' joint policy on the demonstration and the promotion of hydrogen fuel cell vehicles, I think in the next couple of years, China will see massive efforts put into promoting and developing hydrogen fuel cell vehicles. In addition to China, countries like Japan,
其实包括美国、日本、韩国都有相应的支持的政策。大家可能在上海地区，大家开的传统纯电动车开的用户也比较多，是吧？那我想纯电动的这个发展的历程来说，大概也是10年前，先是国家部委出台一些这种支持纯电动汽车的这种，也就10成千辆的这样的政策，然后慢慢的推动了电动汽车在全国包括全球的这应用推广。所以我想对于这个任何的一个新的技术，它的这个规模化应用首先离不开政策的支持。对于燃料电池汽车呢，现在来说呢，去年来说，国家部委也是出台了这个支持燃料电池汽车推广示范应用的通知。所以说呢，在这个这是一个先为期4年的一个推广示范。预计到4年结束呢，整个的这个保有量呢会突破，也就这4年期间，这个产销量会突破5万辆。另外呢，除了中央政府给了很多政策支持之外，其实燃料电池汽车发展的这个起点还是先从地方政府推动的。上海是推动燃料电池汽车发展的非常重要的一个城市，而且上海市也是第一个出台地方政府来支持燃料电池汽车发展的一个城市。所以之后呢，其他的城市也陆续出台了一些地方的支持产业发展的政策。除了政策之外呢，可能大家也很关心，尤其是今天很多都是博主、贵金属行业的一些从业人员，他们很关心那氢能燃料电池的发展跟我们
Is PGM related to development of the hydrogen power? So here I give you a breakdown of the components of fuel cell system, including the most important, the fuel cell stack. So the fuel cell stack is composed of catalyst membrane materials, and catalyst is just of great importance to fuel cell stacks. So this chart showed you the overall breakdown of the cost of the catalyst and other systems. So the stack accounts for about 50% of the system. The system is just like a traditional motor or powertrain in a traditional vehicle. In other words, the stack accounts for 50% of overall cost of the powertrain, whereas catalysts account for 44% of the total cost of the membrane electrodes. Catalysts and the membrane electrodes are very important components. So just a breakdown of the overall cost of the fuel cell systems.
So if you look at the cost breakdown for the battery fuel cell, catalyst accounts for a very big part of that. They have to use a lot of catalysts. So we do hope that going forward in the future, as we try to scale out the fuel cell vehicle, and we hope that we can gradually bring down the usage amount of the catalyst. But this is something you have to use. You cannot get rid of it. So that's why for the industry, this is a very big positive. And then following that, I have done some prediction about the total amount that we have to use or something. So hereby, I would like to have some sharing with you for the PGM. In the hydrogen industry, how do they get applied? And what about the prediction and forecast of their demand as well? So just now, I was talking about the upstream, midstream, and downstream of PGM in hydrogen. But throughout the different application areas, we have to think about the PGM for the upstream, for the hydrogen generation. As I mentioned before, going forward, we hope that we can use renewable energy like water hydrolysis to make the hydrogen. So that way, that is to say that you have to use like iridium. At the same time, we have a lot of battery storage technology, hydrogen storage. So about the organic, liquid organic hydrogen carriers, LOHC, they will need to have a lot of PGM as well. Downstream for about the platinum usage is even bigger, not only in transportation, OEM, high-speed rail, and vessels, and also the airlines as well. So all of those different scenarios will need to have like the as the catalyst. So on that note, we believe that think about in the hydrogen economy, as we develop the hydrogen and fuel cell industry better as they grow in size. With that, we gradually increase our demand for the PGM. So this is a chart about the past 10 years. So think about the curve of our PGM usage over the past 10 years. From the chart, you can see that for the platinum and palladium and iridium, etc., the demand is on the upward curve. So let's go back to this one. So now let's try to think about the hydrogen fuel cell vehicle. We believe that actually fuel cell vehicle is the largest scenario from this one. You can tell that now all over the world for the PV, I think a good case in point is the Toyota and Honda, etc. Hyundai. So Toyota, think about their car model right now. They're iterating it to the next generation. For Gen 1, car is about 20 grams of platinum. But for Gen 2, about 2 years ago, Mirai has been rolled out, which is a fuel cell battery vehicle. So think about the loading. For the platinum is about 8.4 grams per car. So we have done some rough calculation. It's safe to say that for per vehicle, per car, this is the demand they will need to use, which is a huge volume. Based on the target of carbon peaking and carbon neutrality going forward, hydrogen and fuel cell battery for sure are going to become a very important pathway to achieve the double carbon targets. Based on that metric, think about the existing available stock need to be very big as well. They are going to need a lot of that. A lot of industry organizations, institutions for the 2050 and 60 for the fuel cell battery vehicle as well as the hydrogen demand, they have done different predictions and forecasts. So this is a chart about the rough estimation. From this one, you can tell that because we have 2050, 60, etc. But I'm going to talk about 2030, which is very near us. I have done some focus as well. Of course, aside from the passenger vehicle, which is in big volume just now, and then fuel cell battery vehicle has been used a lot in the commercial vehicle. This is a very important user scenario because BEV, its application in CV has a lot of limits, and the limits must be addressed by the fuel cell battery. So that's why I think about the passenger vehicle for the fuel cell. I believe that the fuel cell in CV is going to welcome its golden period. Let's assume by the year 2030, suppose globally the installed capacity is about 4.5 million to 14 million units. So this is based on the Hydrogen Council, and they have done some prediction. On the basis of this prediction, it turns out that think about the platinum demand. As technology are improving, the demand for platinum and also the platinum loading will be declining. But in terms of the absolute number, this will be very massive scale. So in cumulative terms, by the year 2030, the cumulative demand for platinum will be about 100 tons. I mean, a cumulative being defined as starting from now until the year 2030, instead of just like the 2030 that year alone. So from the scale and the sheer size perspective, So think about the PGM in the hydrogen vehicle is going to play a very pivotal role. And here today, I feel very pleased to be part of this conference. I really hope that going forward for the PGM family and also for the industry associations in the PGM and the different companies, we hope that we can engage in more deeper cooperation. So just now, I shed some light on the application scenarios of PGM, but they are confronted with challenges technology-wise, industry-wise. As a new technology, the technical standards are the challenge right now. There are some problems for that as well. Of course, cost is very important. So that's why we really hope that in the future, so for the hydrogen fuel cell industry, we hope that in the following areas, we can make some proposal from the government perspective, from the enterprise perspective. We hope that stakeholders can work together to develop our industry together. To begin with, we have to increase the technology level of key technologies by bringing down the cost. Think about the cost of a fuel cell battery vehicle as well as the hydrogen refilling station. Cost is very high. If you want to scale that up, you have to bring down the cost. Secondly, we have to reshuffle the whole supply chain. We hope that the industrial chain and also the value chain could develop simultaneously at the same time together. And also, in addition to that, for the emerging new technology, if you can scale that up on a massive scale, you have to come up with standards, regulations, legislations, and policies as well. So that's why from the government perspective, we hope that they can have some positive policies as well, like the NEV, like purchase tax should hopefully be further cut. And then, so there was this about 4-year different pilot period. We hope that after the first pilot program has been finished, a lot of cities can measure up with their city level support so that from the central and the local level, we can promote the application of the fuel cell battery. Of course, the hydrogen fuel cell battery is a new technology. It's not something that can be easily handled by any nation or any industry alone. So this is not like a low-hanging fruit. We will need to collaborate with our international partners globally. Going forward, we need to strengthen our international collaboration in order to promote the scalable development and application of the industry. With that, I finish my presentation. Thank you.